Hello, everybody. It's everyone here knows me. I'm Joel Lessem. I'm Executive Director for PeerScale, and this is my first time introducing a power session. I'm excited to say just to let you know, we're going to be doing 6 power sessions annually, sort of the months in between quarterly dinners and the annual retreat. And we're going to have a mix of topics ranging from, marketing to sales to development and things that keep you up at night. And I'm hoping, and we're going to be, this session, by the way, is being recorded. It's going to be posted on Slack afterwards. And we're going to have Q&A at the end of the session. So hang around for the end should you have questions. And we will be sending out a poll. Your feedback's very important to us. We got some great feedback from the last session we had on M&A a couple months ago. So very good. Without further ado, I'd like to introduce today's session. We're going to be, we have Simon Obstbaum, who's an ex-CTO. He had a business. He's a founder CTO that he built up and sold, and then he ended up with a team of thousands in development in streaming, along with Igor Denison-Blanche, who is chief of staff at DHL. And believe it or not, DHL apparently has thousands of developers. They have a lot of technology, and they really were trying to figure out after these tours of duty how to measure developer productivity. And they've teamed up with Stanford, the university, to do this research, which they're going to present to you today. And they're hoping some of you may be able to participate in this research going forward. So over to Igor and Simon.
Great. Thank you so much, Joel. And thanks everyone for tuning in. We're excited to share what we've been working on. Let me just start things off by sharing my screen. So you should be able to see the slide presentation now. And before we get going, as you have questions during the presentation, please pop them in the chat and we'll be happy to either answer them as we're going through or otherwise at the end. I know it's a very nuanced topic and you might have questions as we present it. And so today we're going to be covering how we're doing this research. So diving a bit more into the methodology, how exactly are we measuring software engineering productivity? We're also going to be showing some early results of our research. We're working on publishing a number of papers, the first one of which hopefully will be out this year. And then lastly, we're going to invite all of you to participate in the research in case this would be interesting for you, where you would be able to measure your own organization's developer productivity, benchmark yourself against peers in your industry, and get some real quantitative insights and data from which you can make decisions. So let's start things off by introducing the research team. So leading the science component, we have Professor Michał Kosinski, who is at Stanford, and his research focuses on human behavior in a digital environment. And he's the top 1% most cited researchers, and he was actually the whistleblower behind Cambridge Analytica back a few years ago. And we also have Simon, who's joining us here as well. So Simon, why don't you go ahead and introduce yourself?
Yeah, hey everyone. Joel, thanks for the warm introduction. It's really great to be here with PeerScale today. So very briefly, I've been leading software engineering teams for over 2 decades now. I'm originally from Germany, but I've been working most of my life outside of Germany. I've been a lot over Eastern Europe, Asia, and spent a good part of my professional life in San Francisco in the Bay Area. As Joel mentioned, I was running a video streaming service. Back then, it was part of AT&T Warner Media, has been acquired by Sony. I had a large engineering team, hundreds of people, not thousands, but still pretty decent, I'd say. And I've always been intrigued about, how to get the most out of my teams and help them perform and help them deliver. And I've been focusing a lot on KPI system. And when I left the company, relocated back to Berlin, I thought I should take a closer look at software engineering productivity. So as part of some M&A deals I was involved with, I was asked to guarantee a certain level of productivity, and I had a measurement problem. I didn't know how to answer that. So, when COVID hit and I had a bit of time at hand, I started to take a closer look. At one point, I reached out to people at Stanford, and I was introduced to Igor and subsequently Michał to take this research forward together.
Yeah, thank you, Simon. And then on my end, in a previous life, I was chief of staff to the CEO at DHL, the logistics company. And like Joel said, because of the number of package movements, shipments, trucks, warehouses, and whatnot that DHL has, they actually employ a small army of software engineers. And as chief of staff, I was leading a number of digital transformation projects. And for me, it was always very paradoxical how software engineers are so data-driven, and yet we were making all these decisions impacting our engineers without good quality data, right? And so then let's start things off with a poll. And basically, we would like to understand what is the main factor that guides decision-making in your software organization. So this can be anything like headcount. For example, can I reduce headcount without affecting productivity? Or work model decisions. Are we better off doing remote or in the office? Perhaps it's outsourcing. If you want to understand how productive your outsourcing partner is, maybe it's performance benchmarking, right? So how is my team's productivity relative to the past or to other teams? Could also be things like cost efficiency. So how cost efficient is my team? Or even external benchmarking. So I'm sure all of us have had to answer these questions in the past. So I would love to understand what is the main factor that guides these decisions once you had to do them. So let's take a moment to answer the poll question. All right, so I'm not sure how many answers we have coming in, Lori.
Yeah, we've got a bunch. I'm gonna let them keep going for a little bit.
Sounds good.
Yeah, and then I will show the results in about 2 seconds. Here we go.
Wonderful. All right, so I'm not sure if you guys can see my screen with the poll answers. Can you see it?
Yeah, everyone can see the answers. Yeah.
So it looks like the vast majority of people selected delivery expectations as their main factor that guides decision making, right? And so second in is productivity metrics, and then we also have, to a lesser degree, team status updates, intuition, and someone even said office politics is the main thing that guides their decisions. And I can say I've been there, and I know how tough it can be sometimes. So that's quite interesting that we're seeing delivery expectations as the main driver. And to some degree, let me just close my poll. I think that delivery expectations can be tied to any of these 4 components, right? So as leaders, we rely on productivity metrics, maybe team status updates, intuition, office politics. And as engineers, we probably want to be relying a bit more on productivity metrics rather than the subjective things or even the less measurable stuff like delivery expectations, right? How can I really measure that? And how can I quantify that properly to understand how am I doing, whether I'm kind of not just meeting or not meeting my roadmap, but rather kind of like, what are the reasons? How does this compare against my industry and whatnot, right?
Well, what I want to add here is, so for example, I was working in an organization that would use exactly that. Like if you hit your roadmap commitments, you were good and you delivered. The organization was, let's say, somewhat larger. So we knew we had inefficiencies, but we were just layering people on top. So we would meet the delivery targets, but I would argue that we were no longer very efficient, but we had a very strong business model, so it didn't matter so much to us. So I think it's very common actually that people, if you deliver what I want you to deliver, then I'm happy with your productivity. But it kind of prevents you from doing actually better than you could.
Yeah, exactly. And so we find that a way to really stay grounded in objective, quantifiable data is to zoom in on the productivity metrics. And we would also now like to understand if you could pick one of these main metrics, which one is the one that your organization currently uses the most? And so we have lines of code, DORA metrics, story points or t-shirt sizes. Maybe it's number of commits or number of pull requests, or perhaps it's also even burn down charts. So let's take a moment to answer those.
We've got lots of people responding. Just going to give them another 10, 15 seconds, and then I'll show the results.
Sounds good, yeah. And some of these can be used in combination, right? But we're looking for kind of maybe the main metric that you're using to really understand how your team is performing. All right, so we have the results coming in, and 75% of you voted story points and t-shirt sizes, and then the rest, lines of code, DORA, PRs and commits, and burn down charts seem to be roughly at around 7%. So story points are definitely a very widespread way to measure productivity, but actually all of these have their own flaws in their own way, right? So we have here the four main buckets of metrics, right? And actually story points out of the four that we looked at are not objective. Doesn't mean they're not useful. It just means that, they're not objective, and that you can have one team which estimates a task, and then once this team has to estimate another task on the next day, you don't really know if that same task is truly equally comparable, right? So you're kind of a bit almost guesstimating there. And secondly, the problem there is that you're also not able to compare story points across teams, even internally, right? And let alone externally. So they're almost like relative. And actually, none of these metrics analyze the source code written. And this is a problem because you can hold any of these constant and change the source code, and you're going to have a very different type of work being delivered in those, right? You can have something which, for example, is 50 lines of code, but have a very different impact on the software you're building. And because of this, actually, none of them are very reliable metrics. They're the best we've had until now. And, we acknowledge that in absence of anything better, this is what we have to work with. But they're also quite easy to game. And we can see this in the next slide. So we can start off with lines of code. And the problem here is that more lines doesn't always equal more productivity. And in fact, once you start measuring lines of code, people start writing longer code. And this isn't necessarily what we want, right? With story points, as I touched before, these are subjective and they're not comparable across teams. And also more story points doesn't always mean more productivity. You can have cases where, because you're kind of agreeing, playing, story point poker or whatever on these, you might have different metrics for similar tasks or all kinds of variations there. And actually, as soon as you start measuring story points and really drilling down and measuring your productivity using them, people are going to be inclined to inflating the number of story points a task takes to complete. With DORA metrics, these are a bit more nuanced. And for those that don't know, DORA metrics are a set of 4 metrics. And what they do really is they measure more delivery speed rather than content. So it's more so a measure of CI/CD adoption and not productivity, because just because you're delivering fast doesn't mean that what you're delivering is actually good, right? So it's directionally correct, and it was more useful in the past than it is now, because it's actually relatively easy sometimes to rank elite without truly having elite productivity. And once you start measuring DORA metrics, people are going to start prioritizing speed over quality. And then lastly, we have number of commits or PRs. And again, here we run into the problem that more commits or more PRs doesn't necessarily mean more productivity, right? It kind of depends on the contents of those commits and the contents of those PRs. And as soon as you start measuring people on this, you might people might be inclined to deliver smaller commits or smaller PRs. So I want to pause here now in case anyone has any further questions on this. I'm not sure I'm able to see the chat actually, but perhaps I can do this. And Lori, I don't know, should we leave questions for the end, or how should we do it?
Yeah, let's leave questions to the end. That was kind of the
Okay,
plan. I don't see any questions
beautiful.
in the chat at the moment. Yeah.
Sounds good. All right, so we've taken a look at these, and I'm happy to expand on these a bit later. But my point is that our existing metrics fail to accurately measure productivity, right? And this is a problem because we're missing out on untapped potential. And I'm citing two studies here. The first one was which was done externally at Stripe through a survey of thousands of developers and C-level executives. And it suggests that your team could be moving 50% faster. Whether this is 20% faster or 60%, I think most of us can agree that there's probably some untapped potential left in our teams. The second study, which was done at Stanford by us actually, suggests that the top 25% of engineers actually generate 50% of the team's output. And the bottom 25% generate only 8% of the team's output. Now, this is food for thought, and I have to add that these metrics in isolation of context can be dangerous, right? Just because I'm down here and not delivering as much output as someone in the top bucket doesn't mean that I'm not doing a good job. Maybe my roles and duties were not as much as writing code as they were, managing or doing other tasks that are not reflected in the source code. But what this kind of points to is that there is a lot of room for improvement in the composition of our teams. And the more research participants we add, the more we see some variation of this pattern show up in many teams. So then let's take a look at the third poll. And the question here is, if you were to evaluate your software team's performance relative to your industry, in which quartile would you think it falls? So we have 4 quartiles. So the top quartile, which is the top 25% of companies. Then we have the next 25%, which would be above average. The third quartile would be slightly below average, perhaps. And then the last quartile would be kind of like those bottom 25% of companies, of teams. All right, so we have the results come in, and we see here that actually 50% of us think that we're doing great. Maybe not, like there's some room for improvement, but we're doing pretty good. About 40% think that, hey, we're maybe below average and there's some potential for improvement. And then about 13% think that, hey, we're doing pretty well. So what I will say is that it's a relatively small group that we have here. So it's not entirely reasonable to assume that we're going to follow like a normal distribution. But I think the fact that nobody rated themselves as in the bottom quartile, and also that some people were kind of a bit more, like I think something like 70% of us think we're above average or higher, right? Speaks to somehow that, I think, Simon, you have some experience with this. Maybe you want to add some comments here.
I can share a bunch of anecdotes. I mean, I was in a bunch of meetups, 10 CTOs in the room. Everybody had the best team in town. Even myself, like I have the tendency to think, because I'm very deeply involved with my teams, that like we would do better than average. Oftentimes I wonder if that's truly the case. I feel you can't really know until there is an established productivity benchmark to really understand where you are relative to other organizations.
Exactly. And thanks for that, Simon. And what our research found is that 1 in 4 engineering teams are delivering between 2 and 6 times more output than the rest. So we have here the 4 quartiles, which we asked you to place yourself in. And I think most of us actually were somewhere down here, right? And statistically, that's where most teams, most organizations are going to be, because this covers 75% of the option space. And so even the improvement from here to here is a 2x improvement. This means you can be doubling your delivery speed, or maybe, decreasing your cost by a significant amount. So the question here is twofold. It's number one, where do I stand in these buckets? And number two, and probably most importantly, how can I move from somewhere down here to somewhere up here, right? And we found that unlike sales and marketing, software engineering lacks good data to drive these decisions. And if we had good data, we could be cutting costs by as much as 30%, which we've seen materialized in some of our research participants. They were able to decrease their costs by this much without impacting productivity significantly. Some of them are on the way to almost, moving 50% faster, like that research suggested. And actually, all of our research participants mentioned that they have full visibility into their performance of their engineering team. And so then what we've arrived at the conclusion is that you can't improve what you don't accurately measure. And our current metrics are a bit flawed. They have gaps in them. They're directionally correct, but we can't really achieve that elite level of performance unless we are using very specific and very good metrics, right? And we thought it's time to stop flying blind and to start using good data to making decisions. And so here enters our algorithm, which we developed at Stanford. And what it does is it measures productivity by analyzing the functionality of code changes in each Git commit. So the way this works is we plug into your Git environment and we analyze the source code changes of every Git commit. So we look at kind of the delta between commits, right? And then we quantify these changes based on their functionality. And I'm going to go into how we do this in a second. And we basically assign, let's call it a score to every commit. And then using this, we understand, or we can combine it with Git metadata to create a productivity metric, right? So we know what user contributed what at what time, and what was the points assigned to that commit. So with this, we can make a dashboard similar to this for a user, although for users, it's a bit less useful than for teams or even for organizations, right? So we can kind of like tally it all up. And the way this works is that the algorithm quantifies the source code changes based on their impact on the software's functionality. And we actually look at more than 30 code-based dimensions, such as cohesion, complexity, coupling, data structures or classes, right? Interfaces, methods, persistence layers, what APIs are you consuming, what architectural patterns are you following, and what are some of the dependencies and dependency injections present in your code, right? And there's many more dimensions that I'm missing here. But the gist of it is that we know this works because we've calibrated this algorithm for 98% accuracy in measurement across millions of files that we've mined from public repos. And we've also calibrated this across 10 languages. And the way we do it is we would grab one file and using LLMs, create 100 different but functionally equivalent versions of the code file. So we would rearrange the file syntactically without changing the functionality, right? And then we would analyze each file using the algorithm and compare the metric, the measurement that we're getting of these 100 plus new files to the original one. And if it deviates more than a couple percentage points, this would be flagged by the system. We would go back, understand why the measure was off, and then recalibrate our algorithm, measure it again, and keep doing this over and over again with, as I mentioned, millions of files that we mined from public repos. And then we did the same thing to calibrate it across languages, which means we've developed a metric that's basically a common denominator across programming languages, right? So we grab the same file and we translate it to 10 plus languages or frameworks. And sometimes this leaves us with some very awkward looking files, but as long as the functionality is the same, that's what we're aiming for. And then once we have these files, we again translate them we create 100 different copies of them, functionally equivalent, but syntactically different in each language. And then we run the measurement, we compare them against the file, and then that's how we know that the algorithm measures the functionality of what we're trying to do with the source code file, right? And this works not just in complete source code files, but also in commits, evidently. And the value of this is that it doesn't as much matter how I'm writing something, right? What style I'm following, but rather we're measuring what's the functionality of that source code. And then where you see productivity come in is that if you're doing something very elegantly and efficiently, you're going to be able to do this much faster, which means your output delivered per time is going to be higher. And secondly, if you're running this on the cloud, you're probably going to be seeing reduced cloud expenditure usage for these files if they're built more efficiently than others, right? So then what does this mean? That with our algorithm, we have something that's objective, that analyzes source code written, and that's calibrated. So it means it's reliable. And it's a single source of truth for output. And it's pretty hard to game. There's ways you can game it, but ultimately, eventually, this will only work in the short term, and over the long term, it's pretty hard to game this, we found. And I'm happy to do a deep dive into the ways we've seen people, or potential ways you could hypothetically game it. So then how does this algorithm help you? In a typical software org, we have leadership who makes decisions impacting your tools, your people, and your processes. And ultimately, all of this flows through your developers. And even the decisions impacting your ancillary functions, your BAs, your QAs, your PMs, all of this, in some way or another, flows through the developers into the source code that they write. And so as these developers react to your decisions, you're going to be able to see this reflected in the source code. With our algorithm, we would analyze this source code, create this productivity dashboard, where you can see your team's reaction to the decision you just made. And what this does is it improves decision-making because it closes the loop in terms of what is the impact of the decision you just made. It's a short feedback loop, and better decisions ultimately lead to better productivity. And so once again, then with our algorithm, what you're getting really is better information, which means better decision-making, which means more output and to some degree, better outcomes as well. And some of the benefits you could realize from this is you can decrease costs, you can move faster, you can improve visibility, right? And have a single source of truth into your engineering organization. And you can use this for your stakeholders, be it at C-level, be it investors, be it other stakeholders, right? And then you can also use it to manage performance if you so choose to, which means you can shift these discussions towards objective data and allowing you to identify and retain your top performers. And as we've seen before, where top performers sometimes make up to 50% of the code base, this is something quite critical for an engineering organization nowadays. All right, so then let's move on to our fourth poll, which is, what is the main practice that you use to increase your software team's productivity? We have 5 choices. First one is Gen AI tools such as GitHub Copilot. The second one could be test automation, such as unit tests, integration tests, or front-end tests. The third one would be code quality tools like SonarQube or ESLint. Fourth one would be CI/CD practices, and the fifth one could be pair programming or pair code review.
So some of these questions have been intended as multiple choice, but
Yeah.
since we're limited to one answer, pick your favorite.
We have lots of answers coming in. I'm just going to wait another 10 seconds to
Perfect.
share. Yeah.
Sounds good. All right, interesting. So we have a pretty even split here between test automation, CI/CD, and pair programming. Then we also have 12% of us using Gen AI tools such as Copilot. and also an 8% using code quality tools. So Simon, I don't know if you want to do some commentary on these results.
Yeah. I think, well, I will add more to that when we discuss case studies. In general, what we see in our algorithm, in our measurements, is that like Gen AI would help the team to increase their productivity. More or less depending on the person's seniority level. We see actually that it provides significant benefits when you have a chat experience that would allow you to understand code that has been written by someone else quicker. In terms of test automation, I think nowadays not so many people argue against it, but let's say 5 to 10 years ago, I've had a lot of discussions like, is it really worth it? Are we really net doing better? Now that we have data, I can see that it is better net. We see that there is a bit of a invest while the practice is being adopted. So you take a short-term hit, but in the long run, there's quite a meaningful gain. In terms of quality, people always ask us like how our algorithm measures quality. So we don't really measure quality per se because it's contextual. What level of quality is necessary for you and your team? What is even like the what constitutes good quality? So basically, what we see in the algorithm is when quality is impacting your productivity, meaning when you have code that is hard to maintain, hard to refactor, then we see that over ongoing measurement of the output would go down if your quality is deteriorating in a function of time. So it's in the end covered. The CI/CD, yeah, I think we talked about it in the context of Dora, and pair programming is also very interesting. So what we see in the data, so I think anything can be done too much. So there is a diminishing return on pair programming. But when we look at how people learned over time, so for example, we looked at people when they were onboarded as a junior person, over time they evolved. And we found that having coaching in the form of pair programming seems to be the way that helps people to grow the fastest relative to any other coaching method or training method. So it just seems to help them work side by side with a senior and understand their decision making and trade-offs. But then, yeah, at one point, like you could also impact your seniors. So we have a bunch of case studies on that. So we'll, I think, talk more in a case study section.
All right, so a bit more language around the way the algorithm works. So the beauty of it is that since we plug into your Git environment, we have access to your entire Git history, which means you not only get real-time insights, but also historical insights. And so if you choose to, you can select any time frame for your data analysis. And if you know that, for example, in May of 2021, you did a big decision where you wanted to see how that impacted your team's productivity, we could give you that data, and it would be a pretty straightforward to get it, because it just entails expanding the time frame of data that we would look at from your Git history, right? So it's useful not just to make decisions that are forward facing, but also to learn from past decisions. And we have a number of case studies where we can dive a bit deeper into this. So for example, this one is a team that increased their project headcount by 12%, and it's data from 2019. So back then, this algorithm was not developed yet. And we can see that in this case, their team output or team productivity, I guess, increased by almost 20%. So relative to that team's mean before, that addition was delivering more output than the average output that every person in that team had before, right? So in this case, this decision was not only I guess the correct one from a productivity perspective, but also from an efficiency perspective as well. We also have another case study, and this is a very simplistic view, where we plotted productivity per quarter, and we're comparing two teams. Team A, which is delivering about 41, let's call them units of output, and Team B, which is doing an average of 33. And at first sight, this appears to favor Team A because, well, they're the ones doing more output. But when we take a closer look at the cost element, we see that Team A actually costs twice what Team B does, right? And so then on a cost per output basis, Team B is actually more cost efficient. And so depending on what you're trying to do with this team, you would make one or the other decision using this data. And I think what it highlights is that our algorithms data can be connected to financial data or, for example, cloud spend data to make these like level 2 or level 3 insights and decisions, such as this one. Then here we have another case study where one company replaced 42 Bay Area engineers with 41 in Poland and 5 in India. And we have here the old team, which shows the number of engineers, and you have a total cost base of 12.5 million. And then the new team with so they left 10 engineers in the Bay Area and then increased their Poland and India headcount. And because the cost in India and Poland was significantly lower, their new setup was, what is this, 5 million less, right? Like 40% less. And if we look at here at the output, it's comparable, right? And so once we graph this, we can see that in green is India, which more or less kind of stayed constant, so it's not as interesting to us. But if we look at blue, this is the Bay Area team, and then red would be the Polish team. And if we look at these this outline right here on the top, which shows like the aggregate team performance, we can verify that indeed the team's output did not significantly change, right? And then this view right here gives us the individual or like the unstacked view, right? So kind of like every team would start from 0 on the y-axis right here. Another case study would be this one where a team that was based in the States, where in the consumer tech space with medium-sized companies working in PHP and JavaScript, wanted to compare their productivity working from the office versus working from home. So in the onset of COVID, they switched to working from home, which we can see here in blue, and red would be working from the office. And then the blue line is the 2-week moving average, which looks quite jagged because of the way you kind of basically the way you merge PRs into the main branch and whatnot, and the way your algorithm works, right? But if we look at the red line, it gives you the 3-month moving average. And so down here, we have the kind of like side-by-side views where you have the red line, which is working from the office, and you can see that roughly we've normalized this to 100%. And then we're comparing this with their productivity working from home. And we can see that it dipped significantly for the first, 3 to 6 months. And then eventually by year 1 or so, it recovered and returned to almost normal. Then another case is this one, where we have a company also in the States, this time in retail tech, a bit larger headcount and a bit bigger team size, but also working on PHP and JavaScript, where if we see down here, this exercise of moving the team to remote did not work out because their productivity never recovered. And so if you're facing with some of these decisions, I know it's a hot topic right now. Hey, should we move our team back to the office? Should we not? How do we use data to make these decisions rather than intuition, politics, or any other kind of stuff that we want to strive away from, right? Another case study is this one where we are comparing the productivity of part of a team, this time in Israel, with 1,000 to 5,000 headcount for the overall company in retail tech working in Java. And here we have 2 graphs. The top one shows the 30-day moving average of each person's output. And the bottom one is kind of like the smooth 3rd-degree trend line. So we can see kind of what each person's productivity was over this period of time. But what we notice right here is that the senior B in this case was performing at a 30th percentile relative to this industry average, which leaves you with a bunch of questions as to this person's performance. And what we want to highlight here is that it's important to marry this data with context, because once we dug into this case, we understood that senior engineer B's lower output is explained because he or she was assisting the junior people and actually doing a lot of the, let's say, team lead exercises that the actual team lead or the lead engineer was supposed to be doing, right? So it was a bit of an interesting case study, this one. All right, so then let's move on to our fifth and final poll, which is, what is the predominant working arrangement in your organization nowadays? And so we have three options: fully remote, hybrid, or in office. And I think here I know that some parts of the team may be remote, others may be hybrid, but we're looking for if you could just pick one, since we're kind of limited to one, which one would be most representative of your organization? All right, interesting. So we have actually nobody that says they're fully in the office. 60% of us say fully remote, and then 40% say hybrid. So I'm thinking those case studies on the companies that moved to the office would be pretty relevant for this group. And actually, what's also interesting is some early results of our research that we can see here, where we compare the productivity or the output of engineers based on their work location. So I will preface this with a disclaimer that the sample size is maybe a third or half of what it should be to be statistically significant. But we've went ahead and kind of shared this anyway, because I think it shows some interesting data, right? So we have here in red, it's the engineers that are working from the office, and in the x-axis, we have their normalized output as multiples of the group median. So 1x, this would be your median engineer. And then 2x would be a person performing twice as good as a median engineer. 3x would be 3 times, right? And then frequency is basically how frequent this happens. Don't try to kind of add up, like 0.5 here doesn't mean that 50% of engineers are doing this much. It's a bit of a different thing. It just means how frequent this happens, right? Kind of ignore the units here is the way I would read it. And then here we have the kind of box and whisker plot, which shows that actually those working from home seem to tail on the left side more towards bad productivity, but also there seems to be more outliers. And actually, when you look here at the data, the top 16% of people working from home actually outperform their in-office counterparts. So they exceed or equal the top 5% of in-office performance. But then also similarly, or not similarly, but opposite, right? The bottom 12% of those working from home actually struggle because they seem, based on our data, to be delivering less than 5% of the median productivity. So if you ask me, this is either someone who's struggling or who has silently quit or who just kind of needs the support of someone that they were getting from the office. And so we see here all these kind of different breakdowns. So work from home versus work from office. And typically where from home starts to overtake from office would be somewhere, as we see here in the 80th or so percentile. I think that if you remove these bottom 12%, you would see a bit of a different picture, right? But in terms of quartiles, we see here that the top quartile would be already outperforming from home compared to the office. The bottom line here, though, is that we've seen all kinds of different cases and we've been surprised ourselves. And so this really depends on each organization and their culture, on the team's location, time zones, right? What service they're working on and whatnot. So the best advice here is to really, this is some data which suggests some things, but ultimately the best way forward here is to really get your own organization measured. And actually, we've already partnered with dozens of organizations that are participating in our research. We have, from 10 people startups to large public companies participating. And so far, we've measured thousands of repos, thousands of users as well. And with this being said, we're extending our, we're kind of extending the amount of research participants we are inviting to join us. So we've done a number of waves already, and we have some really good accuracy in terms of the algorithm. But ultimately, we need a lot of data to be able to draw conclusions to help us write our research papers, because there's a lot of permutations in terms of location, seniority, tech stack, working environment, use of Gen AI tools. And so we're looking at probably a sample size of tens or even hundreds of thousands of engineers. And so we're inviting you to participate in our research, where you can measure your software team's output and receive complementary insights. And so we're looking for teams in any geography. We say here that preferably 50 plus engineers, because this kind of smoothens out the data. But if you have something like 20, that's also fair game. You can get some very valuable insights from that level of or that size of the team. We support, for now, mostly object-oriented languages such as PHP, various forms of JavaScript, Java/Android, Python, Objective-C, Swift, Go, Ruby, .NET, C#, and ASP. And the way to participate in this research is quite straightforward. So it consists of 3 steps. We would first integrate with your Git repository, which is a similar level of access that you might already be giving to some of the CI/CD tools you're already using for, optimizing your developers' performance and experience. And then secondly, we would basically gather the list of Git users that are contributing to your Git, and you would need to provide us with some non-confidential metadata about them, such as how senior each person is, where are they based out of, are they working remote or from the office, are they a full-time employee or a contractor, and this kind of stuff. And then you would be able to receive these results, which would give you some really great insights into how your team is performing, and also give you a benchmark relative to the industry average to see whether there's some potential for improvement that you can capture. So I've talked a lot. I think this is basically our presentation.
Yeah, let's take a look at the question. So, so I think the question with regards to how the onboarding works has been covered by the slide here. It's a relatively straightforward integration as long as the programming language is supported. If you use any programming language, as long as it's object-oriented, still reach out. We're building a wait list as we need to decide like what programming languages we will next calibrate our algorithm on. So it might be a fit at a later point in time. Let me just take a brief look at the chat. So with regards to how long it takes, yeah, we're a small team of researchers. So we're kind of like 8 people in the ballpark. So it's our time is limited, and we have to, have meetings, calls to help you with the onboarding. So typically, I'd say turnaround time is 2-3 weeks. Yeah, at this point we deliver a Tableau dashboard on your data where you can see, and you can slice and dice it yourself, see the breakdown across teams, technology, individuals, and get a few common analysis that we run and a benchmark against the mean of all our study participants so far. So that's a relatively straightforward process. Yeah, with regards to confidentiality. So the question is just to drill into your about the same access as other CI/CD tools comment. Does that provide you with remote access to the source code? Yes, we do need access to the source code. So basically, that's how we built the score. Our hypothesis is that anything that you do and your way of working and the tools that you use are in the end reflected in your code and in the way you deliver. And that's what we're trying to pick up on with our algorithm. So we do need source code access. What that means is that we take each commit, we look at it, we build the score. However, we don't store it. Yeah, we just run analytics against it. These are ephemeral workers. So the code is analyzed for a few minutes and then it kind of goes away. So for large corporates, we do have an on-prem solution, but we don't support it for smaller teams just because for us it's too much overhead to onboard. With regards to the team size, I see a message here, only 6 coders. It's a bit on the lower end. We're working on actually publishing a tool that would allow you to connect your GitHub or your repositories to our algorithm yourself. And once we have that, then you could do that. So definitely reach out. Right now, the manual onboarding is a bit too much overhead since we're a small team, but once we have a bit more automation in place, we'd be happy to get you on board. So I see a question from Cosmin. He's asking, the algorithm measures if we write good code, how can it be applied to help us write good enough code that delivers maximum customer satisfaction in the least amount of time? Okay, I guess you need a tool to measure your customer satisfaction. You need to tie that into the output measurement and a software quality tool such as SonarQube or whatnot. And then you kind of juggle the metrics and see which rate of output delivers the best result. Yeah, it's a bit of trial and error. So, but that's how I would go about doing that.
There's I don't know if you saw it, but there's a question from Courtney asking about confidentiality. So if they were considering joining the study, one of the first questions they'd be asked by their board or is about confidentiality.
I think that was already answered. Thank you.
Oh, yeah. Okay. Thanks.
Yeah, I'm just checking on the other question.
There's one asking if can they mention collaboration with Stanford researchers if they participate in this?
You could, and we're also considering including in the papers that we publish a thank you note with all the companies that made this research possible by supplying their data. We have actually had study participants that presented our data to their board or to investors or potential investors to demonstrate that they deliver well, that they have a capable engineering organization that is able to, implement what the company needs. So that is fair game. There is no cost. We're doing this really just for the research at this point. Yeah, we want to publish papers. They will be peer reviewed. We will offer them to journals, and we're trying to get a biggest possible data set. Yeah.
And there's a final question from John. Can you see that in the chat?
Yes. No. So the question is, if I understood your calibration correctly, use public code repositories to calibrate your algorithm. Essentially, the output of the algorithm is as good as the public repository code is. No, I think not. I think that's maybe a misunderstanding. So how do I explain that? So the score, the difficulty with the score is you can't use lines of code, right? Like because you have engineers that are more verbose, you have people that write more dense code. It's different depending on the language. Some languages are more verbose than others. There's different architectural pattern. So it's more a scoring calibration. So the the repository code is just, it gives us more variance to train the algorithm on, but it doesn't limit the algorithm in any way. Yeah. I guess the validity of and accuracy of the algorithm is pretty well documented at this point. I think if you would have joined the study earlier in the year, there would have been a higher risk, and we couldn't have promised, if there's any value at all to you. But since we have, looked at the results, looked at the measurements, and we have, done surveys based on the results, talked to the people, and this has been confirmed by practically all of the participants in the research. So it's pretty meaningful at this point. So I saw another question asking about how long the study has been going. I started to work on this in early 2020 and started to come up, with ways to go about this. Igor and I, we then met, Igor, what was it, sometime last year?
Correct.
And we started to run first versions of the algorithm early this year, I believe March.
And then two final questions. How long has the study? Oh, you just answered that. What's the deadline to respond with interest, and how do our members contact you?
So we don't have a deadline. I think the research will keep going at least for a year. So naturally, we'd like to have more participants sooner than later, but we understand that the timing needs to be right for you as well. So whenever you think you're, or even if you're not quite sure, feel free to reach out. I think maybe on the PeerScale level, you could share our LinkedIn profiles and contact details with the group. That would be
will.
nice.
I'll provide some information in the Slack channel. I'm just going to launch a final poll, which is we always ask people to rate our power sessions. So that is now up, and I wanted to thank you both for taking part in this.
Yeah. Thank you so much for having us.
Yeah, thanks so much, Igor and Simon. This is really fascinating. I said it when I spoke to you earlier as this non-technical CEO, as much as a technical one. I always found we measured like crazy in sales and marketing, but we had the development was a black box as far as productivity. And so, I'm really interested to see the feedback from technical folks on this as well, because I think it would be very helpful. So thank you so much for your time. And I can assure you this group is pretty excited about what you're doing.
Our pleasure. Thank you for having us.
Okay. Cheers.